To complete the square on a quadratic of the form ax squared plus bx plus c, when the a is a positive 1, it may help you to identify the a, b, and c that you're working with, as I've already done here for this equation. Let's look at y equals x squared minus 8x plus 10, our equation right here. Here the a is a positive 1 already, b is negative 8, c is a positive 10. So what I did is I rewrote that equation, just giving myself a little bit of room to work. I grouped together the x's inside parentheses and left the plus 10 on the outside. Now what we're going to do is we're going to identify the b term as the negative 8. We're going to take half of that, which makes a negative 4, and we're going to square it and add it inside the parentheses and subtract it on the outside of the parentheses. So if I take that b over 2 term, which we said was a negative 4, and I square it, the negative 4 will square to a positive 16. This is what I want to add inside the parentheses up here. But if I add something to an equation, I change the value of the equation. So to keep it the same, I also have to subtract the 16. But I'm doing this for a specific purpose. By adding the 16 in here, this will factor into a perfect square. So when I subtract the 16, I don't want that to mess up what I'm doing, so I'm going to subtract it over here on the outside with the 10. Now I can look at the parentheses and try and factor it. That factors into x minus 4 times x minus 4, which is x minus 4 squared. Now, an easy way to remember it when you're completing the square is that whatever you get here when you go to factor it, it always factors into x plus whatever this b over 2 term was. That's the purpose behind completing the square. It will always factor that way. That'll be especially useful when we're dealing with harder things to factor, like fractions and decimals and so on. Alright, so once we've grouped that together, we factored it into x minus 4 squared. Now we've still got to deal with this on the outside. So we just combine like terms there. Plus 10 minus 16 will make a minus 6. So here is our completed form, where we've rewritten the expression by completing the square on it. Notice that if we multiplied it back out and combined like terms, we'd get exactly what we started with, the x squared minus 8x plus 10. Let's work a second example. Let's start with the expression y equals x squared plus 5x minus 4. So now here my a is a positive 1, that's what we needed. My b is a positive 5, and my c is a negative 4. So I'm going to group together the x terms again, x squared plus 5x, and leave that minus 4 on the outside for right now. The b term, the 5, we divide in half. Well, I'm going to leave that as 5 halves because there's no way to reduce that fraction. But then we square it. B over 2 squared would be square the top, square the bottom when we have a fraction, 25 fourths. So now we're going to add that 25 fourths inside the parentheses and subtract that 25 fourths on the outside of the parentheses. Remember, inside the parentheses always factors into x plus the b over 2 term, which is 5 halves, squared. Now I need to combine these on the outside. So to do that, since they're fractions, I need a common denominator. So I recognize that this is 4 over 1. So to get a common denominator, I need to multiply the top by 4 and the bottom by 4. So that'll make it 16 fourths minus 25 fourths. Now combine those together and we get x plus 5 halves squared minus 41 fourths. And we've completed the square on it.